Pretty cool. Guys, we've been doing a lot of multiplying and stuff. And guys, when I've asked you to FOIL some things like, I don't know, say like x plus 5 times x plus 3 like this. Okay. If I asked you to FOIL that out, what would you do first?
X times x.
X times x would be the x squared part, wouldn't it? Yeah. Okay. Well, what about, so the O and I stand for do outside and inside. So if I did outside, what would x times 3 get you, kids? 3x. And what would inside get you here?
5x.
So those are like terms. 3x and 5x would combine to plus 8x. And then how about my last terms, 5 and 3? Okay, so guys, you're programmed to multiply. You're good at adding. You're good at subtracting. You're getting really good at dividing and doing synthetic division. 3.4 on Monday, the part you're going to finish up is instead of expanding or multiplying, they're going to say, you know what, instead of working this way, I want you to start taking something like this and then work backwards into something like this, which is called factoring. Now, I know you've done a little bit of factoring in the past, but the factoring in this section is going to get pretty intense. There's going to be a lot of rules on it, okay? And Monday, you're going to cover pages 2 and 3 in your Chromebooks when you get time in class here to watch notes. But I want to get through this first page today for everybody and just kind of work with that there. So the question we're trying to ask or answer today, I should say, is how can you factor a polynomial? That's what we're after today, okay? So our goals, we've got to be able to understand how to factor polynomials, and we're going to use a pretty important thing. This is pretty important right here. Factor theorem, okay? Now, guys, I don't want you to lose sight of what we've been doing. Synthetic division is going to pop up again a lot in this. Not so much today, but on Monday when you watch the rest of this, it'll show up quite a bit. So let's get some vocab down here before we go. Guys, factored completely is this. Factored completely is a polynomial. It's a polynomial written as a product product meaning what operation, kids? Yeah, it's going to be a product of unfactorable polynomials. Okay. So I'll let you get that down. I'll give you an example of kind of what's happening here, and then we'll get all these down. We'll get example 1 done today for sure. But guys, an example of factored completely is like this. It'd be something like if I had 3x to the third minus 18x squared plus 24x. And I want to ask myself really, what things do we multiply together to form that polynomial? And as I look at this here in red, guys, how many terms are really up here? Okay, look at those right there. And I kind of messed up. That should have been a plus a 24x at the end. Put an x right here after the 24. Okay, take a look at that, guys. Isn't there an x in all 3 terms? So couldn't an x come out of all 3 terms? Think about the values 3, 18, and 24. What factor could you take out of all those? 3. So couldn't I take a 3 and an x out of all of them? Okay, and that's kind of what we're going to look at when we factor monomials in example 1. But guys, think about this. This is what it would become. If I take a 3x out here, the part that's left over, if I take 3x out of 3x cubed, x squared is left over. Okay? If I take 3x out of minus 18x squared, minus 6x will be left over. And this doesn't necessarily need to make sense just yet, but here's the deal. That's how that would factor to start with. Okay? Now the question is that factored completely? And the answer is no. All right? The only thing I've pulled out is what, kids? 3x. Now, when you get quadratics like this, and we'll see this, it's kind of like undoing the foiling that we did up top. Guys, take a look at this negative 6 in the middle, okay? I've got a middle term of negative 6x. What's the last term, or the constant over here? Can you guys think of 2 numbers that would add to negative 6, but at the same time they would multiply to a positive 8?
2 and 4.
What kind of 2 and 4?
Negative 2.
Yeah, negative 2 plus negative 4 would be that negative 6 in there. And then negative 2 times negative 4 would make the plus 8. So factored completely in this example would be like 3x times x minus 2 times x minus 4. Okay, so we're going to be doing a lot of that. Okay, again, that may or may not make sense right now. Right now, not a huge deal. Okay, but that's just an example of what it means to factor something completely. Okay, next thing I want to look at here, guys, is factor by grouping. Okay, another name for factor by grouping is, I call it splitting. Okay, all right. So factor by grouping is usually going to have 4 terms. And an example that you would have would be something like this. It'd be like t to the third plus t to the second, maybe minus 8t minus 8, like that. Okay. How many terms do you see in that example? Okay. When you're trying to factor by grouping, guys, you are factoring by grouping pairs of common monomials. This is a definition. I don't really care for the definition, but it's grouping pairs by common monomials. Mono meaning what? Okay, and we'll see some examples like this on Monday. But guys, if you see 4 terms, and they say, hey, factor this. If you see 4 terms, typically, they want you to split it. Okay, you're basically going to split it like this. How many terms do I have left with that black line? There's 2 of them, right? And how many are to the right of the black line? You split it into 2 and 2 and you'll work. And then Monday you'll see what happens with that. But if you ever see 4 terms, pretty good chance you're factoring by grouping or splitting it in half. Working with the left side, working with the right side. Okay. Guys, quadratic form I'm not going to get too involved with here, but the definition for quadratic form would be something like this. It takes on the form AU squared plus BU plus C is equal to 0. So an example of a quadratic form, this is what I really want to show you. Okay, another example would be like this. If you had something like, I don't know, maybe x to the 8th power plus 8x to the 4th plus 15 like this. Okay, we're used to quadratics being of the form where, what's this power right here that I just highlighted? Squared. What's this power really up here? Well, it's really a 1, isn't it? Okay. Quadratics are also going to happen here, guys. This could also be considered quadratic. Notice, how many times bigger is this degree out front than my middle term degree? Twice as big. What do you notice right here? What's the degree of this function over here? What's the degree here? Okay. You ever see the A term have a degree that is twice as big as the B degree? Like that? Quadratics can come into play. All right. So the A degree can be twice as big as the B degree. Quadratics are going to happen again. All right. So you'll see something like that. Guys, 0 of a function. 0 of a function is simply the value that makes a function equal to 0. It's kind of like the x-intercept. All right. And that's what I want you to get down for 0 of a function. If I gave you this function right here, kids, f of x equals 2x minus 6 like this. Guys, what value would you plug in for x to make that equal to 0? In other words, 2 times what number minus 6 would turn into 0? Okay, so x equal 3, we would consider x equal 3 is a what here, kids? Well, we'd call it a 0 of the function, okay? When I plug 3 in, doesn't that make the function 0? Would you agree with that? Yeah. Okay. And then, guys, you know synthetic division. Okay, it's a shortcut when dividing by x minus k. It has to be a single x minus or plus some number, okay? And we looked at a lot of that in section 3.3 today. We looked at a lot of that in section 3.3. Guys, vocab-wise, do you have everything down here? Okay. I'm going to run through one problem here quickly, and then I'm going to get you the rest of the notes on example 1 here. But guys, example 1 is say factor each polynomial completely. The title of it says to Try to factor by finding a common mono, meaning what? How many terms are in this first example, kids?
3.
Okay. Can you look at those 3 terms and say, okay, what would be common to come out of each one of those? What's one common term I could take out of all 3 terms there? I can take an x out of all of them, can't I? So I'm going to pull that x out front. Okay, so we're taking an x out. If I take x out of x cubed, what's left? If I take an x out of 10x squared, what's left? If I take x out of 24x, what's left? Okay, so now, guys, kind of the same game. Don't I have a quadratic here? Just a 1x squared in parentheses. So the question kind of begs itself again. What 2 numbers would add to 10, but at the same time multiply to 24? So I could say that this is going to factor completely into x times x plus 6 times x plus 4. Now, guys, the parts that I continue to put in parentheses, can they break down any further? Can x plus 6 be broken any further? Can x plus 4 be broken any further? So, guys, what did we multiply to get x cubed plus 10x squared plus 24x? What had to be x times x plus 6 times what? Okay, let's try the next one. What could you pull out of 5y to the 6th and 125y to the 4th? I could take close 5y to the... I can't take 5 because how many y's are over here? There's only 4 possible. So you guys agree that I could take 5 out of each and then y to the 4th out of each? Okay, so this would leave me with y squared minus 25. Now, guys, is 25 a perfect square? Okay, this is that one where if you have a squared minus b squared, that might work backwards into a sum and a difference, a product of binomial sum difference. What's one? Because I took a 5 out of 125. I took a 5 out of both. Does that make sense? So 125 divide 5 would get you 25 there, Henry. Okay. Now, guys, if you remember the sum and difference rule from previous sections, this would be 5y to the 4th times y plus 5 times, yep. And that there would be your factored completely right there. Okay. All right, last one. We're trying to factor out a common monomial. Guys, do all of these terms have a variable in there?
No.
So I can be able to take a variable out of all 3? No, but what could I take out of all 3? I could take 6 from everything, so let's do that. So I've got, good morning. I've got a 6 I can take out. I've got a, if I take a 6 out of this here, this will be, what's left when I take 6 out of everything, friends? Yep. You want to fill in the rest? Good. Plus. Okay, same game, guys. You have a quadratic where your leading coefficient in that quadratic is 1. What's going to add to negative 4 and at the same time multiply to positive 4? Negative 2, negative 2. So what's this going to look like in completely factored form?
6x.
Yep. Minus 2 times. There it is. Some people get kind of tricky and they'll write this as 6 times, guys, that quantity, z minus 2. How many times is that getting multiplied together? Be to the second power then. Another way would be good there, okay? All right, guys, that's as far as I wanted to get with that. See, remember,